Oh, welcome to today's webinar. We will be running a live Q&A at the end of this webinar. So if you have any questions, please feel free to go ahead and add them to the chat window, and we will address them at the end of the webinar. And if you miss anything, don't worry. We'll be sending a recording of the webinar as soon as it's available. So thank you for coming today. We're very excited to have Professor Hala Nelson presenting on AI-powered digital twins of real organizations, aspiration, and reality. Professor Hala Nelson is a professor of mathematics at James Madison University and the author of Essential Math for AI, which was published by O'Reilly in 2023. And she's also the author of the upcoming book, AI-Powered Digital Twins, which will be published by Wiley in 2026. She specializes in mathematical modeling, AI and data strategy, digital twins, and consults for the Departments of Defense, State, and Emergency and Infrastructure Services in the public sector. Her expertise lies at the intersection of mathematical modeling, data, AI, digital twins, real-world industrial and military applications, and AI and data strategy and governance. She sits at the intersection of critical sectors, including the military, the government, and the industry, realizing the commonalities they all have in terms of available resources, struggles, and AI adoption strategies. So thanks for being with us here today, Professor Nelson.
Thank you, Janet, for the introduction. Thank you, Max and Janet, for helping me set up for this call, being patient, and also thank you, Tom Sawyer Software, for inviting me to give this talk. Thank you, everybody, for coming to see me speak live today. As I think Janet just made a nice introduction. Thank you for that. I will go ahead and share my screens, and we're gonna pick it up from there. It's gonna be this one. It's always when you have like 20 windows open at the same time. I'm gonna do slideshow, and we are set. All right, so we already saw this. So the introduction that Janet gave, I think it's more than enough, but I wanted to add to that just sitting at the intersection of multiple industries at the same time, academia, military, government, and industry gives me a kind of a good vantage point on what kind of struggles and lessons learned that organizations who are trying to adopt this new technology and with large potential, what they're going through, and what would be a good strategy, what would be what hurdles they face, they overcome. So that's basically why I'm here, and I'm trying to share this information with you. So I keep going back to every time there's a huge hype around something. For example, there was a hype around generative AI 2 years ago, a hype around now AI agents, a hype around digital twins. It's always good to go back to the basics and think about, instead of riding the hype, think of what exactly are people trying to do, and what are the fundamentals, and how are we gonna get there. So I'm gonna stick to my own definition of intelligence. I never really define intelligence. That's a big philosophical existential question for us. So what I do is I define aspects of intelligence. For example, what differentiates a human intelligence than other forms of intelligence, or from inanimate physical objects? It's usually these aspects, for example, perception, understanding, control, navigation, memory. And think of this definition, these aspects of intelligence, and think of the machine equivalent of those. For example, memory, databases, imagining. For example, simulation, generation is the machine equivalent of imagination, dreaming, communication, creating tools, improving with learning, reasoning, logical, causal, ethical. So when you think of intelligence in terms of what aspects make intelligent, creates intelligence, or how does it manifest itself, then when you think of what we're trying to do with the machines and with artificial intelligence, we're trying to replicate aspects of our own intelligence, make the machine do them, create models and hardware and communication networks that are able to achieve all aspects of intelligence or parts of it, and talking to each other. So perception, for example, involves computer vision, audio, communication involves language, speaking, etc. So this brings us to AI agents. And again, I'm going to stick to my own definition of AI agents because we have now thousands of AI agents deployed everywhere in our systems. We are already interacting with them. So what is an AI agent? It can be pure software or have physical robotic body. It can be solving one task or flexible, exploring, manipulating its environment, building knowledge with or without an aim. It learns with experience. That's a big aspect of intelligence, is learning from examples and from mistakes and reinforcement learning, etc. It gets better at performing a task with more practice at that task. It perceives its environment, so perception, navigation, builds, updates, or evolves a model for the environment, and then perceives, analyzes models, make decisions. Making decision is a huge part of our modeling process. It's not only important to understand the data and replicate it and generate similar data. Our goal is always to make sound and fair and ethical decisions based on the automation process that we are creating. So making decision is a huge part of trying to accomplish our artificial intelligence, and okay, and also this understanding of cause of effect is a huge aspect of our human intelligence. In particular, we are able to differentiate between just observing a pattern in the data, or to actually say this event caused that event. There's a sequence of events and how to model that mathematically and on a large scale. That's actually a very important problem, and our machines should have a causal model inside them as well. And this one, the last one here, I got from LinkedIn. When I posted this definition on LinkedIn, another person suggested this as part of AI agent definition is a collaboration with other agents, and I added or humans to achieve common goals. So this brings us back to here, the communication, the collaboration to create and achieve common goals. So that is how we're going to think of intelligence and agents in the context of our what we're trying to create, the digital twins and everything that we're trying to create. So we are like thinking, what's the AI state of the art, and how are the real world deployment journeys in real organization going on? What we would like to accomplish is move beyond pilots and prototypes. It's where everybody's at right now, and for that we have to overcome growth challenges. We have to identify how do you move beyond this to and what are the challenges and how to overcome them, and we have to deliver real value, because you can invest all of this time and money and infrastructure to deploy the technology, but then how do you define you have to have a clear understanding of the value you're delivering with this new technology in the context of your own organization. I was in Las Vegas the other week, and I was chatting with these like humanoid robots at the Sphere, and I thought they were insanely close to real gestures, real life. So that brings us back to my first slide about intelligence. It's pretty impressive. And then I generated this guy here using a Canvas AI generator, and it generated something that looks exactly the same as the picture that I just took in Vegas, and I was like, oh, that's cool. Anyway, I did not prompt that. Okay. So first, since we're talking about deploying AI in large and complex organizations, we have to acknowledge the elephant in the room. The elephant is AI going to take my job? And the answer, the answer is, I would say, four-leveled. First of all of us are understaffed and under-resourced. So automation always helps our workflows. In that sense, it would help. It would not take away. For example, we don't have enough truck drivers, so autonomous trucks can help fill the gap. Or think of your own workflow and what part of it can be automated. It will increase productivity and satisfaction of employees. I use AI in my everyday life now, and I love it. Even creating presentations used to take me like I don't know, say a new presentation would take like, I don't know, 3 days to create. Now it takes a couple hours. But however, if your workflow is task oriented, then AI can replace employees whose work is only task oriented, because AI is geared toward, at least agentic AI is geared toward accomplishing tasks. And if that task can be automated, then yes, your job will be taken away. And then the other elephant in the room that organizations face is that there are too many tools. So there's too many hype cycles, and there's too many companies trying to push AI solutions left and right on you. So what you would need as an organization is a vendor agnostic technology communication partner, would know your business, know what tools you employ, whether you need to be whether the tools you can use them, the same tools you can grow from them, or whether you need to replace your systems, design solutions, look for platform will best suit your needs, accompany you through the discovery journey with the vendors, and advocate for your needs. So you need people who know your organization as consultants, not like large consultants, just a person who is well versed in the landscape that currently exists. The aspiration vs reality. Of course, our aspiration is everything is automated, efficient, secure, and ethical. And the reality, and as I say always, this is not a rant. I'm not saying, oh, this is the reality. We need to change the reality in order to bring this technology into the organization. It's not true. And this is the reality. We work with the reality. The reality is that the people and the culture, the humans, their turf, their personalities, is how do you get buy-in with, how do you change a culture to accept and use and innovate with this technology? There's always a policy and regulations. We'll talk more about that. There are industries that are way more heavily regulated than others, so deploying AI is very different story there than in less regulated industries. And this is an engineering perspective here. The technologies and the systems, there's all kinds of instances in organizations. For example, Salesforce instances, there's thousands of them. There are all kinds of stuff that are just incompatible and don't work well together. And if you want to deploy AI on top of all of that, there has to be some sort of interoperability. We have to streamline, so we have to think more closely on how is AI going to talk into everything that's all the data that's in your organization, and there's the security levels. There's a lot of questions here. There is AI. It needs expertise from multiple backgrounds. For example, needs IT, needs the subject domain matter experts, needs engineers, needs solution architect. It needs a lot of people that are all very good in their own disciplines, but they don't understand the language of the people of the team that they're working with. So they all are very well trained, know what they're doing, but to put them together, and they all have different philosophies on how things should be done. For example, in terms of data modeling perspective, in terms of data governance perspective in your organization. everybody has a different background and different way to do it. And so these people should start learning from each other, talking to each other, and highlighting the commonalities and what is how to take each other's strengths to push the thing forward, as opposed to like sticking on to their own to their own training paradigms. Of course, there's the hype cycles and differentiating hype from not. Um, in large organizations, there's always competing interests and conflicting authorities. You always find a department saying, "Oh, but we do this. Oh, but we do this way. No, but this is our territory. This is our department." So this is a big hurdle to overcome. Is how to make people buy in and understand that working together and collaborating will improve efficiencies throughout the organization. And of course, the moment administrations change, whether all the way up top, for example, the government changes and then new executive orders start getting rolled at you, or whether within your own organization, the moment change administrations change and suddenly the priorities change, suddenly pilot programs get dropped, you would be halfway through and then this, for example, the AI task force gets dismantled. Something that you've so that's also part of the reality, that the reality on the ground is dynamic and always shifting, and you have to operate within that reality. And of course, there's always a question of resources. Resources are almost how it is, chronically insufficient. And in a way, AI might help with that. All right, so what is the current state of AI investments and enabling infrastructures? We have a $500 billion target investment. The digital twin industry is predicted to grow from 11.37 billion now to 137 billion by 2030, and I'll say why in this talk. We have a lot of sovereign data center initiatives. We are worried about security of our data, and we want sovereign AI. So we want to bring it all here in the US. We have a national energy emergency. Our energy supply does not satisfy our energy demand, so we need innovative ways to supply at least the data centers, or come up with models that consume less energy and more efficient hardware. So we need optimization at all levels. And again, policy and regulation. There's always the data and AI acts that are getting rolled at us. And they're in a way evolving in a separate realm than the technology itself. So sometimes there are regulations that are like, well, this doesn't apply to this technology. So it's important to have experts sitting there also devising these policies. There's also the competition and AI race. And the competition AI race is both for markets and for the dominance. So it's a national security issue as well for us. For example, we all saw what happened when China's DeepSeek got rolled out. The market crashed. A lot of the market crashed because of that. So what was special about DeepSeek is open source. It's cheaper and it's smaller. So, however, of course, we have to assess real capabilities of the model. Just because something is rolled out and hyped up, it doesn't mean it has the exact capabilities that you want for your deployment. And of course, there's security concerns at all layers. Did you download the file and read the code and see exactly what's going on at each layer of these models that you're using, the open source models? So the security is huge for us here, especially in the digital twin industry. And I'll talk more about that. But however, this makes the case for us to create smaller and cheaper models and to have edge compute, AI on wearable devices, compute happens on the edge. So all of this is an incentive for us to improve what we have now, and there's a huge room for improvement. And here's the AI supply chain. If you look at it, if you think about it, what is a full AI supply chain? There's the data, there's the models themselves, there's the hardware that's running these models, there's the communication channels and networks, they're sending data back to the data center between your own organization, how fast this is happening, where are you pulling it from? Of course, there's the data centers and the energy and power supplies for the data centers, because if all organizations are all going to be using AI, these two matter a lot here. And of course, once you have the stuff set up, you have the system design, has to be optimized, data engineering, engineering. I'm going to talk more about this here, standard of care, again, compliance. In order to optimize and fulfill the technology's potential, all of these layers should coordinate with each other. So usually what we have is specialists here, especially we have siloed communities. If they talk to each other, the whole supply chain will be optimized. And we also have to have when we train our workforce in our academic settings, we have to create programs that talk to the aspects of all of these together. We have to have experts that know the supply chain and know how to think about it, what they're doing in connection of where it's headed next. So that's there's a lot of in academia, a lot of universities now building similar such programs, but we need these programs to be really well thought and so as to create the right workforce. All right, so what happens is with the supply chain for digital twins is exactly the same supply chain as AI. Digital twins, they bridge the physical and the digital reality. So now we're at a level that we have the infrastructure to merge digital and physical realities, and that should improve the efficiencies of both the physical, and if you have digital replicas of your physical objects or systems or processes, and these digital replicas are dynamic in the sense that they get real-time data from the physical or real process, physical object or building or real process that you're trying to understand and make decisions. You can make decisions faster. You have full visibility. There's a lot of advantages to digitally twinning physical objects and processes and real processes. However, when you bridge digital and physical realities, then the security becomes a huge issue, and you really need to have security built into your design process. So again, I said we have the right infrastructure. So what changed in the past 2 years? Data engineering have matured. Generative AI removes access barriers. So you don't have to have an IT person in each department building your systems. With generative AI, you can have knowledge domain experts collaborating lightly with IT in order to deploy AI into their own workflows. So this is a huge barrier, access barrier, and that's removed. And when you remove access barriers, you can scale. And that's huge. This is why generative AI is really popular. And then we have massive investments in data and AI infrastructures to include energy, all kinds of energy now, and to satisfy the demand and to drive the cost down. And those public-private partnerships that are being, the barriers for public-private partnerships are being actively removed in order to scale and get things going. What also changed? Before, we used to have all the data sources. They have to go to data warehouses or data lakes or data lake houses. In the process, before you're able to use this data in your organization or even find it, in the process of doing that, the original data loses context, and we have a lot of enterprise data modeling conflicts. So if you want to model the data or implement a new ERP or a new CIM at your organization, there's always there's always conflicts in how to do that in the modeling. What happened now with the age of AI, with AI native approach, is AI agents plug directly into hundreds of data sources. So AI can take data in all kinds of modalities. It can take web pages, you just put the URLs and have AI analyze it along with images, along with prompts, along with audio. It doesn't matter. You can plug directly into hundreds of data sources. That's a huge difference in how we do stuff. And then you do stuff with it, generate reports, execute action plans, trigger alerts. So in a way, the age of AI is working with a decentralized reality, which is a very, very big difference and capability that we did not have before AI. So an AI agents work with the reality. All right, so well, as I said, we have thousands of AI agents, human and AI generated. The limit of what you want to do with the AI agent is basically what you want to do with it. It's like you know your work, you know what you want to do. The AI experts don't know your work. However, AI, I mean, this is really the potential is amazing. However, as always, when something can be used and applied at scale, it can be deployed for both good and bad purposes easily. So in that sense, we have, even though we have the required infrastructure to build digital twins of buildings, processes, organizations, we have two imperatives. And these are more important than ever. The imperative for an engineering standard of care, security should be part of the engineering process. And the other thing about engineering standard of care, usually people focus on ethics, ethics, ethics. In a way, ethics is subjective, and what's ethical for one group of people could be completely foreign to some other group of people. So in a way, an engineering standard of care is different than ethical standard of care. Engineering is when you have a building, a physical building, you have an engineering standard of care that actually you have to comply and you have to build according to certain standards in order to guarantee the security of the structure. And this should be at this point in our physical, digital, blended realities, we have to build with a standard of care, with a similar, because the safety is paramount, and the threats are real and at scale, and it's different. With before, say, with a real life weapon, you can hurt 1,000 people, 2,000 people. If it's nuclear, then say 100,000 people. But with an algorithm, you can hurt millions or billions of people at the same. So the scale is not a joke in this domain. And then as I said before, we have the imperative for an end-to-end AI native approach. So we have to rethink how we're going to automate our processes and our stuff given that we have an AI native technology. And if you are a person who is lucky enough to come to this field as an AI native, meaning you did not have any of the previous paradigms, and then you have this technology at your hands, in a way, the way you're modeling, the way you're thinking will be AI native, kind of like children. They just interact with the AI now, and they're able to do all kinds of stuff without having a second thought of, oh, I need to build, say, a warehouse first, etc. They don't think like that. They just plug in and play. What's a digital twin? I've been talking about digital twins, and then what is it? It's any digital copy of some physical object or a real process. So it doesn't have, for example, in construction, it could be a digital twin of a building. You have sensors everywhere. You have it could be of the structure itself. It could be of the security inside. It could be anything really. It could be a dashboard. That a Google Earth, for example, is a digital twin. It's not dynamic in the sense that that there is no real-time, updates, but it can be made like that with the help of AI. So digital twin doesn't have to be of a physical object, can be of a process. It can be a dashboard where you're getting all your data from physical objects in real-time processes. So basically we've been always having digital. We've been trying since the digital age. We've been digitally twinning anything. The difference now is that we can interact with these digital twins in real time using AI. We can make sense. We can make more sense of the data that this digital twin has than we ever were able before, because the models are more the models are better than before. There's the modalities of data. There's the digital twin. You can create reports. You can communicate with natural languages. A lot that we can do now as an AI-powered digital twin than before. So just a bit more about the engineering standard of care. So as I said, we've been building digital twins since the dawn of digital age of anything. And however, the complexity and the faithfulness to real life objects or processes have evolved, which is good. That's what we want. The internet has interconnected everything for us. For example, the thermostat in my house is connected to the internet, and everything. We are starting to exist in a fully connected reality, in that bridge the physical and digital worlds. And of course, AI enhances the functionality. However, as much as we can do with that and have visibility and make decisions based on this amazing thing, we have new vulnerabilities. For example, think of attacks on our critical infrastructure through keyboards, attacks on our water systems, our hospitals, and all of this is done through keyboards. And now you don't even have to, or in the future it would be through, or now if you want, it's through voice prompts. You don't even have to be a person who knows how to use keyboards. You just have to be a bad person with bad intentions, and you can really create a ton of damage for entire nations. So this is an imperative for engineering standard of care. We have to implement safety and security, and we have to create people, workforce well versed in cyber and AI cyber, which is different because AI pulls from all kinds of directions. And how do you secure your systems? How do you make sure only people with the right authorities are getting the right responses for the right prompts, etc. So the whole design process is different. End-to-end AI native approach. So if you are thinking end-to-end and thinking of the whole AI supply chain, hopefully this will pave the way for more powerful and small models and optimize AI workflows. And then, so here's a question. I mean, that's, I'm a mathematics person. So these are the kind of questions you want to be thinking about. Is how can we devise model that we can base explainable decisions on where we don't have mathematical clarity, and what we can conclude from adding more data and computation, what we can't. For example, like so the larger the models, and the more data and the bigger and the more performative the AI chips are, and all of this, I mean, but how did we don't have like full mathematical analysis on does adding more data to this model improve its performance? It's like these simple questions that should be answered. We should have brains converging to answer these questions, because this will help us engineer more optimized and less costly and less power consuming systems. And then And then so this is related. It's like, for example, if you engineer, so our data, for example, our data is everywhere, it's completely anchored, completely chaotic, and that's the nature of it. For example, so if you put the math and models on top of this chaotic, messy, large data, it's different and less efficient than if you engineer the data. For example, I'm going to say an example in real life organization today, and then put the models and the reasoning and the AI on top of the anchored data. So these are the kinds of things you want to be thinking about. All right, so the hurdles for real-world large-scale AI deployments. The people involved in AI adoption come from different. Excuse me. So the people that come from they come from different backgrounds, level of expertise. So you have data experts, you have data scientists, you have data engineers, you have IT people, you have AI experts, you have the stakeholders, you have the intended users. So all of these are different communities. They have different values. So if you are thinking, oh, I am a quantitative person, well, you're very different than a person who does finance, who does data scientist is different than data engineer. Once you get into this, you're like, oh my gosh, you guys think very different ways. We need to talk to each other. Both of our work will be better. And then so what I noticed also is that it's easy to have like one application. Say you have one data set and you want to create to make the decisions based on that. That's easy. Make I don't know, locate the fire station based on historical call data in the past 5 years. That's like a problem I worked on with the fire department. That is easy. In the sense that it's all like models, mathematics, it's easy. However, the AI that I've noticed is difficult to deploy in organization is that when you want to automate a process that exists in your organization. So that has to do with your whole infrastructure. Where is your data and how is it being updated and who's securing it? So that's what's the pipeline. So to create pipelines to automate workflows, that's different than one-time use cases when the data is finite and you just do something with it to solve a problem, a business problem. And so AI needs to be part of the automating infrastructure. It's not like a separate model that gets applied after data is requested, retrieved, cleaned, and analyzed. AI security is different than traditional security. As I said, AI pulls from all kinds of places. We need to secure who's accessing what and who's getting what answers. That's just one part of it. The bill in organizations is huge. To do a pilot program is very different than deploying AI for everybody in the organization. Then who shoulders it? Is it the department? Is it the individual? Is it the whole IT? Who shoulders the bill is a huge question in real life deployments. Environments, a different story. And also, I noticed that most organizations do not have an AI deployment strategy. So basically, AI usage is diminished into few toy problems. Here and there, some employees start using it personally, which, by the way, they should not be using it, especially if their data is secure. You cannot just pour questions into an unapproved AI in your organization. So there's a lot. For a strategy, I actually wrote a strategy here that starts with assessing your AI maturity level, survey your technology, assess supporting AI, and avoid duplication, duplicate expenses. There's a lot in the strategy. It includes data governance. It includes identifying the people or organization who can advance the technology and be allies. You need allies at the top. You need allies in the workforce. So I don't go through the slide. It's a lot, but I have this if you want to take a picture of it. Okay. The other thing is your users do not care about what kind of AI you're using in the back end. They don't care if you're using ChatGPT or Gemini. How are you powering your systems? Or if you're applying knowledge graphs or RAGs or whatever new modeling technique there is that will improve the performance of the AI, they don't care. They care about automating their workflows, addressing their pain points. So when you deploy AI into your organization, you want to build for replaceability, because whatever is the back end is evolving, is changing. You want to be able to plug and unplug and not redo the whole process again. And again, it's always you always want to have the costs and the cost benefit analysis, and that should be at the front of your strategy, not an afterthought. So adoption at the organization, I have 3 levels. The easiest part is to popularize individual use of your AI tools. For example, if you have Microsoft Copilot, have people experiment, innovate with it. There's also Microsoft Say Studio if you want to build in your department. So popularize this because people know their work better than you want them. So they know what they want to do with this technology. And that's, if you're thinking of scale, you have to start there with the culture and popularization. The second step, which is more work, is you want training resources for your AI and any approved AI. So you want to propagate an AI-informed culture, you want to disseminate, you can use AI to create this stuff, and you can present, you can collect feedback, iterate. So again, this is a bit more work than popularizing, but it is related. The most difficult step is to model and document the institution's administrative processes. As I said in this talk, we're doing organizational processes. So this is a hard step. It's like if your processes are in some employee's head and not documented in a machine readable way, you're not going to be able to deploy AI to automate or streamline any of these processes. So in this sense, you're going to start with documenting these processes that you care most about, in order to make them navigable by AI. So you must provide this process for all your departments to store and access high quality data. And you can involve the departments themselves. As I said, they are the people doing it, so they are the people who can get involved in creating and documenting the data for their own workflows. And then you can have an AI person, say, in each department, helping them put all that information in the studio, in whatever toolbox you're going to have them use in order to start streamlining and creating chatbots, whatever it is that they need to make their processes easier. So where do you start? You start with what each department, they can start with what process do you want to automate? What data does it need? Is the data digitized? Is it accessible? Or is it just like out there as institutional knowledge that's not really in anybody's head? And by the way, for example, in my institution, we had a huge retention problem for our staff because they could not navigate the processes. So we'd hire them and we'd lose them 2 months later because they'd make a mistake and that no one knows. There's conflicting ways to do stuff. So you have to start with organizing with your pain points, and then streamlining documenting these pain points. And then this is what I'm trying to allude to, is that the business process, that's your pain point, is the one that guides the data model and not the other way around. It's not like I'm going to force everybody to store their data this way and now I'm going to deploy AI. No, this takes a long time, and it's in a way unguided. In mathematics, we have the forward way of doing things, and that's like exponentially expensive. And there's a backward way, which is way cheaper. If you know dynamic programming, you know what I'm talking about. Or if you think of back propagation, when we train neural networks, the reason it works back propagation as opposed to forward is you save exponential amount of time by going this way. You start with the business process and model backwards. You don't model the whole data and then do the business process, and that's a huge difference. So choose a specific administrative process. For example, have one use case succeed, then assign. So each department has a IT consultant, should work directly with the people who are trying to who chose these processes, want them streamlined, and then you scale, meaning this can be replicated easily across deployments because you're using your own workforce with their own pain points, and that's who've been doing this for a long time, and the business process is guiding the modeling, the data modeling process. This is an example of a business process. As I said, we're currently losing a lot of employees. So this is maybe making the case that no one will lose their job. AI will help. For example, we wanted to create a chatbot to produce a process based on documented data. For example, how to hire a person or how to do a small purchase credit card. For example, a small purchase credit card. These are all the departments and the systems involved. I mean, there's a lot of departments involved in this one little thing that people do all the time. These are all the policies that are involved. So here's what used to happen is employees, we would lose them because there's all the stuff they need to know. There's all these steps they need to navigate in order to get it right and not get, I don't know, fire, like have a mistake in the reimbursement process, have money come out from the wrong account, or money go to someone unauthorized. So having this stuff documented and having the AI navigate with the employee on navigate this and create a streamlined process for you, that's a huge difference. So here's another business process. Wait, this is the same. Oh wow. I actually put two of the same. There was another one. Oh, here it is. Okay, pay this person $300. So for example, I go to a conference, I come back, I want to get reimbursed for my travel, for everything. So who is the payee? Is it internal staff, faculty, etc.? And then what's the account? And these are all the documents that go with it. And these are all this is Chrome River, this is a system, right? So there's a lot that goes into this simple processes. So if you can create like a graph, or you guys are graph people in Tom Sawyer, so modeling the business process as an executable graph that can navigate through all of this and help the employee reimburse this person will make a huge difference. So the three approaches that I've seen to address this is that to implement AI into an organization. The bad one I've seen is that throw all the data in a knowledge cloud and then throw a language model on top of it. So all the data, for example, what you see here, that are involved in processes. This doesn't work because, first of all, that data is dynamic. These policies are always changing. As I speak, we got updated policies, right? Who's gonna maintain that? How are you gonna connect the origin source of truth with the thing? You want the AI to be giving the right answers. Now, a better approach that I've seen but gives unguided answer is keep the data where it is, and then you have the security and access controls. It is close to the source of truth here, and then throw an AI agent on top of it. A better approach, the best approach I've actually seen, and this is faithful to the business process as its connective tissue. I borrowed the connective tissue word from John Cook. I really like his approach to doing this. You can look him up on LinkedIn. You model the business process as an executable graph or a flow chart with all the involved components. And then you keep the required data that's feeding into the graph where it is with security and access controls. And then the data schemas are only virtual, and then you throw the AI agent on top of it. So the AI basically is guided by the graph. The graph is guided by the business process. The business process is the data feeding the business process is all exactly where it is, and it's faithful and hopefully with the right security and access controls. This is replicable and scalable because it's the people and the departments who are pinpointing these business processes that need to be automated first. So it's not a large consulting company or a large company coming and saying, oh, you must do it this way according to our model. No, it's you and your business guiding the modeling process. The realistic approach, organizations are not monolithic. My vision here aligns with decentralized solutions. This is consistent with data mesh for analytic data, if you know of it, microservices for operational data, and recently with Olesen Bernier, metagrid for metadata. So decentralization is the reality, but you still need some centralized thing that talks to all of them, understands all of them. As I said, I am an AI native person in the sense I learned about AI before I learned about data modeling, data infrastructures, data engineering, data. So I am, in a way, I kind of studied the AI before I studied the enabling infrastructures. And in a way, I've seen it work in organizations. I've seen this approach more faithful to the way organizations operate. Do not reinvent the wheel. Do not remodel the whole organization. Start small, start with the processes that you care for, and then you can scale. If you have working systems, keep them. Stitch what you have together. That's another thing about digital twinning. And then do modular updates. And then connect and exchange ideas with the people, companies building digital twins. The biggest lesson learned for me is that this is a humbling and exciting world. Mathematics is a superpower, but neither AI nor the models are enough. I also learned that we need to read the historical context of how things evolved and the different paradigms of doing things. For example, past as present of data modeling, business process modeling. These things alleviate confusion and help you not reinvent the wheel. People, administrations, regulations are the reality, work with the reality, not against it. Engineering for scale is crucial. Prototypes and pilots are different than scale. How do you deploy and scale? How do you evaluate performance? Security and engineering and standard of care is part of the engineering. It's not like we build and then we secure. No, we build securely and right away, safely and securely right away. And then of course, you want to make sure that your resources are in alignment with your demand, and always a goal. And we have a lot of space here to optimize because our goal is smaller and more powerful models, and that's where all the optimization, all the people who think. With operations research, with mathematics, they help a lot. Thank you. This is it.
Thank you very much, Professor Nelson. We're very happy that you're here today. In today's call, we discussed hurdles for real-world large-scale AI deployments for digital twins, and also several strategies for deploying AI at real-world organizations, and also the imperative for engineering standard of care, and also for a native AI approach in real-world deployments. So for more information, please check out Professor Nelson's book, Essential Math for AI, which was published by O'Reilly. And then also her upcoming book, AI Powered Digital Twins, which will be published next year by Wiley. And also, please feel free to reach out to us here at Tom Sawyer Software to set up a call with one of our graph visualization, data visualization, and analysis experts. We'd be glad to talk to you about your particular needs. So thank you again very much for being here.